Okay, so we left off somewhere around here in each and every class. I don't exactly remember where each class left off, so what I just decided to do is I'll start from the top of trapezoids all over again. I began by talking about the height of a trapezoid, which is the shortest distance between the two bases. A reminder that the bases are the two parallel sides of a trapezoid. Now, what do I mean by shortest? I don't necessarily mean that it's the smallest number in the problem, but rather we're looking for that perpendicular marking to identify the shortest distance. There are a lot of different distances to go from one base to the next, but only the ones that are perpendicular to both bases will end up being the height. Now, like the triangle, the height could be, and as you can see, I tried to attempt to draw it there, but to no success. It's a little better. It's not too bad. I'm drawing on an iPad with my finger, by the way, so that's why it's going to look so terrible this entire time. Have fun. The height could be on the inside. The height could come from a vertex. Right there. Oh, yeah, that's a beautiful height. Like that. Could even go on the outside. Right? Which means we have to hypothetically extend. We've talked about that before. Right there. Oh, yeah, this is great drawings. This is quality stuff, everybody. And the height could even be a side, which, as we mentioned in some of the classes, that if the height is a side, it has to be one of the legs. Okay? You can see our equation here underneath. Please make sure you circle it or highlight it or whatever you've been doing to emphasize it to find it easily in your notes. It is 1/2 times the height times the quantity of, and by that I mean parentheses, base 1 plus base 2. Now just kind of foreshadowing, we can see that these parentheses are going to be done first, the addition inside of them. And once we've accomplished that, then we can do all the rest of the multiply. We've got another fraction of 1/2, excuse me, so we want to make sure that we are not forgetting about that. Okay? Let us, random mark, let us take a look at the first example here, area of a trapezoid. Okay. Erase all that jazz. So we know one thing about a trapezoid is true, that is the opposite sides are parallel. That wasn't too bad. And neither was that one. Pretty decent there. So there's our pair of parallel sides. And let's call this side 5. Yep. Let's write that 5 a little bit clearer, shall we? Five centimeters. And this one I would say is maybe, it's not quite double it. Not a little less than double. I think it might be 8 centimeters. Wow, that's terrible. I apologize to all out there. Here we go. It's a little bit better at least. Try to make that C a little bit more of a C. Yeah, that was worse. And then we have our height. And we will call that height, let's say, I think it's a little less than 8. So maybe we'll go with 7 centimeters, 6 centimeters, something of that nature. It was 6. Okay, 6 centimeters. First thing we want to do is take our equation. Can't get that 2 drawn in there. There we go. And then we want to plug the numbers in the correct spot. So we've got our height as being 6. And how I know that's the height is it is perpendicular to both bases. Okay, it's not a base, it's perpendicular to the bases. Our bases are our parallel sides, clearly identified by the parallel markers, of which I erased half of them. One of them being 5 and the other one being 8. Okay, so order of operations here just says I'm going to add that 5 and that 8 first. Nice, easy 13. And again, we've talked about number sense and being wise on how we want to multiply these. I'd say let's start off by multiplying half of 6, taking half of 6 rather, and that would be 3, and then times 13 will be 39. So my area comes out to be 39 centimeters squared. That squared was pretty darn good. Okay, one last example here. Well, that stuff's probably going to pop up on the screen again, beware. Okay. And we will use the same equation before, not because they're in trapezoids, but we see the word trapezoid in the very first sentence. Reading through the second sentence, we see the word area. That kind of gives us that clue there. That's the equation we want. Area equals 1/2 times height times base 1 plus base 2. So close to getting it. That 2. Okay. Information we have. Right off the bat, first number I see 3 millimeters. Reading the sentence, that represents our height. Now, I'm not too happy about that because I don't want to take half 3, but let's just finish writing stuff in and we'll see how that pans out, okay? The area, it says, is 18. So there's that. And it says one of the bases is 5. Now, we've talked about this concept before with the diagonals within a kite and rhombus, that the little tiny subscripts, the 1 and the 2, but that are below the B, are there just to say the first B and the second B, which could be different for every person. So this 5 millimeter base could either be base 1 or base 2, just depends on how you looked at it. And in the long run of this problem, it shouldn't make any difference whatsoever. Okay, so I'm going to go ahead and make it my base 2, and we want to find the other base, which in this case is base 1. Now, yes, we would normally say go inside the parentheses and add them together first, but the problem is we've got a variable plus a constant 5, and that's not going to cut it. There are a lot of people that stop at this point because not only do we have this 1/2 that they don't like to deal with, but we've also got addition that we can't do inside the parentheses, and they just kind of throw up their hands and say, forget it. But if we just stop and come up with a plan first, as we've talked about many times, we can easily work our way through this one. Like one of the problems that people have is the 1/2, and we know how to take care of that, right? We're going to multiply both sides by 2, the reciprocal of 1/2, because that's going to get rid of that 1/2, and then we don't have to deal with it anymore. So if I multiply both sides by 2, that's going to turn that 18 into a 36. Okay. Now, all I really have is just a 3-step equation from here. Many people will notice that that 3 is outside the parentheses, and we can do distributive property. In which case, right after I do distributive property, it's a quick 2-step equation. If I distribute that 3, that would become 3 times b1 plus, don't forget to distribute it to the 5, multiplying it, making it 15. I'll go over here to finish. Subtract that 15 from both sides to get 21. Divide both sides by 3 to get 7. My label is millimeters. And it is not going to be squared because this number 7 represents the base. Okay? So I do not need to square the millimeters. All right, so your next step is to download the assignment called Area of Rhombuses, Kites, and Trapezoids and complete that.